Hello and welcome to today's episode of Rawkode Live at the Rawkode Academy. I am, of course, your host, Rawkode. Today we're taking a look at Crossplane, but before we do that, there's a little bit of housekeeping. First, please remember to subscribe to the channel, click the bell, get notifications for all new episodes, and remember to thumb the video, share it, comment, get involved. If you want to support the channel, there are various membership options available. You can check them out on the YouTube page, where we have some live courses currently in flight looking at InfluxDB. Also, we have a rather active Discord server available at rawkode.chat. There's nearly 600 of us in there now, talking all things cloud native, Kubernetes, eBPF, and everything in between. So come say hello, and I look forward to meeting you. Today's session is about Crossplane, and I am fortunate to be joined by a developer advocate at Upbound, the maintainers of the Crossplane project, Viktor Farcic. Hey man, how are you?
Oh, very good. Thank you for having me.
No, it's my pleasure. It's really nice that we get to do something together. I've enjoyed your DevOps channel on YouTube for a while, so it's nice to have you come over here and join us and say hello. For anyone that's not familiar, could you do yourself a little bit of an introduction and tell us who you are?
Sure. So my name is Viktor Farcic. I currently work in Upbound, company behind Crossplane, or the main contributor to Crossplane, and I'm a developer advocate. Now, in the past, I did basically everything because my career can be qualified as Viktor gets bored within a year and then it changes what he does. And that change is either within a company, and then ultimately I reach a point where there are no more things to do in a company. Then I change the company, right? So I've been tech lead, programmer, developer, tester, lead, product something, whatever, everything basically.
Nice.
And now I'm in Upbound, mostly because I've been following and using Crossplane for at least a year before I joined, and then I in a way told Upbound guys kind of like, you should employ me. I like this product.
I think that's great that you found a product that you liked and then just was like, yeah, I should go work there. Like that. I mean, that's how you take your interest and your passion and apply it in a really great way. So nice work.
Thank you.
We got a hello from Russell, who is loving your energy. So thanks you for that.
Thank you, Russell.
And Tomislav from Croatia says, Bok Viktor, I guess.
Oh, zdravo Tomislave.
There we go. Nice. All right. So why don't we've introduced you, so now everyone knows exactly who you are. But maybe people are not familiar with Crossplane. You want to give us what's the elevator pitch? What is Crossplane?
Control plane for everything. I'm not sure whether that's official pitch, whether that's on the website, but that's how I would explain it, right? And so think of it this way, right? When we manage infrastructure, services, and what's not, we are almost always using CLIs, right? Directly or indirectly. You, without naming product, you execute some command in some CLI, and that CLI talks with an API, which can be AWS, Azure, Google, Alibaba, Kubernetes, whatever it is, right? And what people do not really, I believe, comprehend completely is that behind that API, there is always a there is always a control plane. Now, everybody knows control plane, that's Kubernetes, right? We know control plane from there, but there is a control plane behind the API in AWS. There is a control plane behind virtually any cloud vendor, right? At least those that I know. Now, what we are trying to do is create a control plane to manage all those control planes. Because we feel that there is a strong need for those things to be open source, and there is a lot of confusion about, not confusion, but complications, right? I need to do something in Kubernetes, I need to do something in AWS, and then I need to jump into Azure, and then maybe some on-prem, and so on and so forth. And the major difference why control plane is important for everything can be seen in Kubernetes, right? We are moving away from the idea that I should execute a command to create something, doesn't matter which tool we're using, right? Or to update something and so on and so forth. We are now deeply into the era where all those things are managed by control planes, because they're doing more than responding to commands like create something, right? It's more like continuously monitoring the state of the actual state of something, comparing it with the desired state, and making sure that all those things are happening all the time, independently of which order we put things, how we define. As long as we define the desired state, control planes are managing those desired states, right? And that's happening already right now, whether you know it or no. It's just that we are trying to kind of create an open standard for control plane that will manage everything, give or take, right?
Nice. So I guess, a lot of people now they know who you are, they know what Crossplane is, but they might want to compare it to other tools that are on the market. Is it fair to say that Crossplane fits in that same space as Terraform, Pulumi? Is it different enough from them that you think it comes into a new space? And what would some of those differences be?
So to begin with, currently it is in the same space, since our, let's say, entry point, beachhead for Crossplane is infrastructure. But we're definitely not aiming infrastructure being the only thing that Crossplane manages, and it's not. So the scope is different, and on top of that, it's the API is different as well, because one of the things that are very important to us is that there is a single API to manage things. And when I'm saying single API, I'm not now talking about Crossplane, I'm talking about Kubernetes API. Yeah. I believe that Kubernetes API, when people ask me kind of, what is the main advantage of Kubernetes? Usually people think, hey, it can run containers, right? To me, the main advantage is the scheduler and the API that sits in front of it, right? That I can define things, the state of things, and Kubernetes can make sure that those things are happening. And that's not only applying to applications, but to everything, even though applications are beachhead for, just like beachhead for Crossplane is infrastructure, but not the end goal. I think that the same holds true for Kubernetes and its API. Applications are only the first step towards total domination of Kubernetes API, right? Another difference is the control plane, the scheduler that I was talking about. When you use other tools, or most of the other tools, you execute some command and something happens. Yep. Somewhere in the cluster, in your infrastructure, or whatever you're managing. In our case, there is a scheduler with the control plane, with continuous reconciliation, drift detection, and all the things that you expect from Kubernetes applications today just applied to everything else, right? So in my head, at least, there is a huge difference between I want this to happen now and I want this to continue existing and being in certain state forever and ever, or at least until I change my desire, right?
Yeah, I think that's really important, actually. If we talk about those Terraform workflows right now, Terraform only runs when the user asks it to. When the HCL has changed, like if I use Terraform to spin up an S3 bucket and it finishes and then I go delete the S3 bucket, I don't have an S3 bucket anymore. Whereas with Crossplane, we have, in fact, because it runs on Kubernetes, it has that continuous reconciliation. It's going to detect the bucket disappeared and then recreate it for me. And I think that's almost a superpower to a certain degree. Like that's what I want for my infrastructure, right? I mean, everyone must want that.
Correct. I mean, think of it like you can reframe it saying that what I'm doing with my applications, I want that for infrastructure. And what we're doing with applications, I mean, not everybody, but we are all moving into Kubernetes domain for, if not all workloads, but for some, right? And the same example that you said would be, hey, if I delete 2 pods of my deployment in Kubernetes, those 2 pods will be recreated because the desired state is to have whatever the number is. And we are just applying the same logic on infrastructure and services.
Awesome. We got a comment from Ty Martin there saying 2 of his YouTube Kubernetes favorites on the same stream. Sorry, we are crossing streams. I hope that's all right. I don't think we're going to cause like a time space continuum problem or anything.
Let's see. There's still time.
Thanks for the kind words, Ty. We really appreciate it.
Thank you.
All right. Shall we show people a little bit of a Crossplane?
Sure,
Are we
sure.
ready for this?
Let's
Yeah.
do it. Yeah, I am. Let me move the browser so that you don't see infinite. Can you see me now?
Let me pop us over to my other scene. Awesome. Your terminal is now visible. You are live. Take it away.
Okay, so let's say that I have this definition, GK YAML, right? I'm going to start simple and then I'm going to complicate things later on. Now, what this does is basically uses Kubernetes manifests with custom resources to create something called GK cluster and something called node pool. You can probably guess from the names what those things are. And it specifies some properties like, hey, it should run in US East 1, it should have the latest version of the cluster, and locations for the node pool are those, and some other parameters, right? So this is similar to what you would do with other tools, just that we're here talking about YAML, and I'm not using, I don't know, like Pulumi, it would be Go or JavaScript, or Terraform would be HCL. So far, this is more or less, this is just looks like a different format of something that is very similar to other tools, right? The major difference is that I can do something like, I mean, there are many major differences, but to begin with, this is all Kubernetes. It's Kubernetes API, so I can do something like apply -- file name GK, right? Now, I already applied this before I joined the session, only so that you don't wait for long. But basically, you need to trust me. I applied exactly the same command, and then from there on, I can manage this as if it's a normal Kubernetes resource, because actually it is a normal Kubernetes resource. I can say kubectl get managed, which is a catch-it-all crossplane type of resource, and I can see my resources running. You see that actually I prepared it last night. Their statuses, you can describe, you can do logs, you can plug it into whatever you're using for Kubernetes today, which is another huge thing that I didn't mention before, because when you think about it, apart from obvious advantages of Kubernetes, there is the ecosystem that was, I believe, never seen before. At least in my career, I haven't seen any other platform, if you want to call it, have such a big ecosystem. So I could now manage my just as a slight differences compared to other tools. I can manage my resources with Argo CD or Flux if I like GitOps, right? I cannot do that with other tools unless they move into Kubernetes area. I can get metrics from into Prometheus. I can do logging in the way how I'm doing logging in general, and do all the stuff that you normally do with Kubernetes. As a result, I have here a shortcut command. You can see if I put it on a different screen, you can see that my cluster was created. There are 3 nodes, CPUs, and all the stuff, right? This is a cluster now running in Google. Now, one thing that is very important for us, and that's what we call composites. So composites allow you to compose infrastructure in a way, not infrastructure, compose everything, infrastructure, services, applications, in a way that they're much easier to manage, easier to digest, and so on and so forth. Because this was the simplest example that I could come up with. And this is kind of like, okay, kind of an average person can understand this. Somebody who is not a Kubernetes ninja or not proficient with Google Cloud can understand this more or less. But let's say that I want to create a cluster in AWS. What would I need to do? And imagine that I'm a developer, right? I would need to create an EKS cluster. I would need a node pool. I would need a VPC or a couple of VPCs, subnets, internet gateway, and a bunch of other things, right? It gets complex very, very easily. Now, alternative, and this is where composites come into play, I can do something like this. I can say, hey, how about you create your cluster using something like this definition? And now the name of this resource is, in this case, Composite Kubernetes Cluster. This is completely custom. This is imagine a situation where an operator or SRE or whatever the role is in my company said, okay, I will create the composition, I will manage the complexity of all that, and I will create a completely new resource type in Kubernetes just for everybody else. And this one says, okay, I'm going to reference something called cluster Google. Now, for now, imagine that I'm a developer, right? I do not know all the details about everything. So I can select, hey, I'm going to reference something called cluster Google. It could be cluster AWS. Actually, let me change it. Why not? Let's do this. I'm a developer and say, hey, I want to run my cluster in AWS. Cool. I want to have small nodes. I do not know really whether that's T2 something or T3 something or whatever are all the variations in AWS. I want to be as simple as small, medium, large, right? I want a specific version, or I don't want to specify anything because I trust that whatever is the default makes sense, the number of nodes and a few other options, right? Now, this is something that can be digested by everybody, potentially. And what the final outcome is does not depend on me, does not depend on Crossplane. It depends on people in a company who want to provide services to others. So think of this as shift left. And I will show you later what is happening in the background for something to be as simple as that, right? So I'm going to save this change, and I'm going to do, now I'm still a developer, I'm going to do kubectl apply -- file name, and the file is called cluster YAML, and that was created, right? And now I can do something like kubectl get managed, and I should see stuff happening. Actually, I should not watch because there's too much output to fit on my screen. So let's do this. Now, behind those 20 lines of YAML, I got 2 IAM roles. I got 1, 2, 3, 4, 5 policy attachments, a node group, a cluster, a route table, subnets, security groups, internet gateways, VPC, node, and okay, those 2 are Google from before. So I'm going to ignore those, right? So those are all the things that I should have created if I wanted to manage, in this case, EKS cluster in AWS. And I still did not go crazy, right? Things get more complicated than that in a real world situation. Now, the way how all that happened is that somebody before created something like this, definition YAML. So that somebody, call it SRE, right? Defined a completely new resource type for me, and it's calling that resource type, we call it composite resource definition, or XRD. And the name of this new resource is going to be composite Kubernetes cluster. That's the same name that I used previously in a definition when I was pretending to be a developer, right? And there are some parameters defined, like version, node size, min node count. Those are the same parameters that I used before, right? So somebody creates a completely new definition of a resource that explains what are the things that teams in a company care about and what are the things that they want to manage, like version, node size, minimum number of nodes, whatever those things are. And we are going to expose that to them. And by doing that, we are going to shift left. We are going to make those teams autonomous, that they can manage their own stuff themselves without opening issues in Jira and sending it to some other people. So making people self-sufficient by exposing them to the level of requirements or abstractions that they're comfortable with, right? Some other team might need 57 parameters, right? It's whatever you choose it to be. So this is a definition of custom resource, composite resource definition that became later on, when I applied it to the cluster, to the control plane cluster, became the custom resource that I used before. And now comes the madness, right? or I'm going to show you different levels of madness, right? Implementation of that interface that I just showed you for Azure would be this. Relatively small, straightforward. Human cannot comprehend it because in Azure, all you need is an EKS cluster. And I'm talking minimum because Azure can become extremely complex, but I'm really talking about the minimum. If it's, where did I put it? GCP, like the one that I used before I started this session, slightly more complicated. Those are all the things you need to define, no matter which tool you're using, more or less. And now comes, let's say, AWS. The simplest possible I could imagine for AWS. Now, let me go to the beginning and show you what I had to do.
I don't think we have enough time for that, I'm afraid.
Huh?
We don't have enough time to go to the beginning of that file.
Exactly. EKS cluster, so on. It's a lot of stuff, right? Now, what is happening here is this is partly what you would normally see in other tools. Like, hey, there are some parameters that you need to supply when you create an EKS cluster and version and whatever you need, right? And then there are patches. Those are the things that typically would get translated in from what user specified in that YAML that I started with into what is propagated later on to this resource type. Like, for example, if you remember, I used node size and I said small, right? And here I'm translating small to T3 small and medium to something else and so on and so forth, right?
Okay. It's nice that you showed that. We actually got a comment from Russell in the chat asking how those sizes were mapped or configurable. So yeah, there you go.
And you're kind of in control, right? This is not something that is opinionated, vendor specific. Like we decided that whenever people, when I say we, Upbound decided whenever people want small nodes, it will be T3 small, right? You're in complete control. You as a person, necessarily, let's say, you're defining those things. And so on and so forth. So all those are defined. There are some patches that overwrite values depending on user input, and they're all grouped together and end up being something like what I showed initially, which I believe was this file, right? So all what I showed you, all those hundreds of lines and something from an end user perspective, that's what you get, right? And I'm still using very simple examples. Normally, I would add over there maybe to, in that cluster to maybe, if it's, let's say, EKS cluster, maybe I would install some applications like system level applications, maybe Prometheus would be running there, maybe Argo CD, maybe additional stuff, right? So it can get much more complicated than that. But from end user perspective, the interface is whatever you define it to be, right? And that's what we call compositions. And even if somebody doesn't know what that interface is, and let's say that whomever created all that stuff did not document it, no wiki files, no readmes and stuff like that, you can always do something like this. Explain composite Kubernetes cluster and recursive. Now, this requires slight understanding of Kubernetes, but not really out of this world. And okay, so this is actually what my specification is. Those are the parameters, min, node count, node size, version, whatever somebody defined. Off you go, create your own manifests. Be in full control of the things that matter to you and leave the things you don't care about, but are still important, like subnets, to somebody else, right? So it's separation of concerns and shift left in a way at the same time.
Yeah, it's nice. It's like, tools like Terraform allow you to directly access the API to spin up devices or clusters or node pools, etc. But composite resources actually allow you to build platforms within these resources and distribute them and share them across your organization.
Correct. So if I would simplify it greatly, you would think of it as being equivalent of, hey, somebody creates a Helm chart and then everybody else can modify Helm values. But that would be only partly true because we are not talking about some properties file. We are talking about Crossplane creating completely new custom resources that can be used by anybody else.
Yeah. We have a question in the chat from Tomislav, which aligns directly with my interests. So Tomislav asks, what about bare metal or on-premise clusters? Does Crossplane support that?
I'm not sure about bare metal. I would need to check it. I can check it later and get back to you specifically for that question, because if you Google Crossplane contrib, I think you will see all the contributions, right? So it really depends on the community. And if it doesn't support, then it's just one pull request away from supporting it, right?
So there is an Equinix Metal provider for Crossplane, so you can spin up devices. And actually, the focus of my work for the last 6 months has been provisioning Kubernetes clusters through user data alone. So while there's nothing directly in Crossplane provider now, in theory, you could do something like this. So
as long as there is an API that Crossplane can talk to, then yes. Right.
All right. Awesome. Thank you for that. And I think maybe one of your colleagues is joining us in the chat. Grant has been kindly answering questions as we run along. Grant Gumina. So.
Thank you.
All right. Awesome. So that's good to see. I like the way those composite resources are relatively, not easy, but writing YAML is something that we're all getting very comfortable with these days, and being able to define them that way as a combination of other resources within Crossplane. Once it's done once, you just reuse that as much as possible, and you've got this kind of platform provider, which is pretty sweet.
Exactly, it allows you to build your own interfaces, right? That fit exactly your needs.
Because every organization does this stuff their own little unique way, and being able to codify that in a way that is reusable is something that is often lost. And it's something I've seen in the past. It's just that each team ends up doing their own implementation, their own way, and there's all these different variances. And then eventually someone wants to do a security audit, and you're like, why are all these things different? And like being able to codify it in this way removes that whole class of problem, which I think a lot of people need.
Yes, especially when you run at scale. I can't tell you how many times I've seen, whichever tool is used, hundreds of files that are doing exactly the same, but simply because there is a small variation, or simply because the teams do not communicate with each other, and so on and so forth, right? So you want to codify. What you explained actually fits the bill very well. You want to codify all your knowledge in a way and expose it to an interface that contains things that matter and are not repeatable over and over again.
Exactly. All right, we've got a couple more comments and questions. So Ty says a Crossplane with Talos or Sodero would be pretty sweet. I agree. Big fan of Talos and Sodero. That would be a nice integration.
Yeah.
We have a question from Andreas. Is there a way to define more specific validations than just a data type? How does it fail if you mistype small? Are there multiple field validations?
If you mistype small, then you would see that resource not being created, and you would have to go to the resource to describe the resource, and see in the events, like basically with any Kubernetes resource. So we are, and this might be important actually to mention, we are intentionally not trying to build things that exist in Kubernetes ecosystem, right? Like validations we're just following how all the other Kubernetes resources are working, or same thing for logging or for metrics. Or another popular question, which I don't know whether it popped up there, but usually pops up, hey, can you have conditionals, if-else statements? And again, we are really trying to avoid those things, because this is part of the ecosystem. Like, hey, you need conditionals, excellent. Kind of like there is Helm, right? Helm can do those things. Helm can template it. And so we are really kind of trying to avoid anything that is not really, really specific and non-existent. If that makes sense.
It does make sense, yes. Andreas, if you want to add anything to that, feel free to drop back into the comments, but I hope the answer helps. So I quite like that. Obviously, the AWS one is rather massive, because although EKS is a managed service, it is very far from or managed without tools like EKS control or something like a composite resource with Crossplane. But I love the simplicity of the Azure one and the Google one as well. Like they're so easy for people just to be able to play around with.
Yes, I mean, give or take, right? Even the simplest one like Google becomes complicated over time because it's not really, hey, I need a cluster. No, I really need a cluster, and I'm inventing now a database, and that cluster cannot be just GKE. It needs to run something inside. So it's always more than a single resource. Now, what I'm trying to say is that it almost always gets complex. Now, the levels of complexity, depending on providers, differ greatly, right?
Mm-hmm.
And yes, some are easier than others.
Right. Can we do something funny or crazy, depending on how you would look at it? Like you've actually provisioned an EKS cluster there. Is that correct?
Mm-hmm. Yes, I can. Let me double check. Maybe I didn't yet, because another interesting thing about AWS is the speed with which things are happening.
The lack of speed, you mean?
You said it.
Yeah, I don't mind being honest on this stream.
I'm just pushing you towards saying it.
I think the median time for an EKS cluster is around 20 to 25 minutes. It is.
Cluster is still not up and running, and the node group did not start because it needs to wait for the cluster to be created. And this is another thing that I think makes a difference between using a control plane than, let's say, simple CLI, right? I do not have to specify dependencies. Normally, I would need to say, hey, node group depends on cluster, because you cannot create a node group until cluster is there. And that can also get messy. In this case, I did not specify any dependencies because simply control plane's job is to figure out what to do and repeat if it cannot be done and all that stuff, right?
Mm-hmm.
But yeah, you will need to, if it's something funny, you would need to wait until AWS is created, or you can tell me whether that something funny can be done in GKE.
Well, no, what I'm thinking is, right, like if we've got a couple of subnets there, right? So, and they all say true for ready and synced. Now, I just want to show people my favorite thing about Crossplane is the continual reconciliation. Like, can we just go delete a subnet from the UI?
Of course. Of course. Let's do that. This is my account. Subnets. Okay. Here we are. I think that, let me double check. OBF is one of them. Yes. Do you want to choose or number 1 to 3?
2.
There we go. Okay, this one goes out.
Bye subnet.
Yeah, no, it cannot be deleted because
it's got network interfaces.
Okay, let's do this simpler because I don't want to go into AWS madness of dependencies. You cannot delete this because it depends on that, and that depends on something else. Let's do this. Let's go here and delete the node group. How does that sound?
Yeah, go for it.
I hardly ever use the console. I don't know how you do stuff in from web UI. Here, delete. What do I need to do? Team. Okay. It will be deleted eventually, and then give it a minute or something like that. And if I didn't mess it up, it should reappear.
So does that mean that on your CLI you could run kubectl get node groups?
Oh yeah. Kubectl get node groups, right? And right now it's synced. Soon it will detect when it's deleted. I will actually watch it, right? Kubectl get node groups. At one moment, it will change sync to false, and it will change ready to false, and then it will change ready to true again.
Yeah, so that's Crossplane is what? It's just checking that every 1 minute, 4 minutes, something like that. So there's some interval, right? And the fact
there is. I think, and don't take this as written in stone. I think that the default interval is 3 minutes or something like that, just not to bomb providers with requests, and it can be changed, right? You can configure what that interval is. That's actually, hey, look at this, ready false while talking, and then periodically checks things and makes sure that everything is synchronized and all the jazz. Let's see what's happening here. It's still deleting. Man, you cannot even. Oh no, there we are. It's ready.
Nice. That's the node inside the node group.
This is okay. I'm definitely confused with configuration. As I said, I'm not using web UIs. Deleting still. My bad.
We'll need to wait for AWS to catch up and for that to disappear, and then Crossplane can maybe go and try and create a new one with the same name. So who knows how long that's going to take. But all right, cool. Yeah, it's just nice, like the fact that it even noticed that it wasn't ready, and the fact that it's going to be able to resync and recreate that. I just think is a really cool property of Crossplane that we haven't seen in this type of tool to date until really Crossplane came along. So just taking it. Sorry, on you go.
Yeah, sorry. That specific thing, actually, I don't know how far back you go, right? But we had it with Chef and Puppet. In a different way, right? It didn't use Kubernetes scheduler and all this stuff. And I'm not now glorifying Chef and Puppet because that would be the last thing I would do. But some sort of reconciliation loop existed. And after that, it was lost. And now we have it again.
Well, I mean, I preferred SaltStack's take on it with its high state and its minion-based check-ins. But yeah, you're right. Chef and Puppet did have agent-based setups as well, which would on an interval rerun their recipes and their manifests. So,
exactly.
Yeah, you're right. I was just trying to be nice to Crossplane, but I take it back. It's crap. I don't like it. Okay, so I mean, we don't need to sit and watch for that to lean. Maybe we can check on it in a little bit. Was there anything else you wanted to show us, or do you want me just to keep throwing random stuff at you?
Go random stuff. I like that more than me having prepared. I mean, I have random manifests that I can show and run, right? But hey, if you have random questions, even better.
Well, yeah, so let's put this on of the lens. I mean, and I am relatively new to Crossplane, so I've got this lens anyway. But if I want to get started, how do I work out what providers are available? How do I work out, what I can actually do with Crossplane?
So, no, that's wrong address. Crossplane.io. Okay. So getting started is where you would usually go and follow the instructions. It has, I'll be honest, there are things to be improved there, but it's a good starting point. And regarding providers, there are two, let's say, types of providers. Those that you see, actually, let me make this bigger. Those that you, and let me do this. Okay. Those over here, right, are the providers that are official. And then there are providers that are not official. Like, when I say official, it's kind of strange, but let's say providers that are exist for a while, that are proven to be working, that passed all the tests and everything that we expect them to do, which does not make them perfect. And then there is, what did I want to do now? My keyboard is going crazy. Crossplane contrib, which is where everybody else can contribute, and eventually things from here will go to the docs. Like we recently worked with Civo folks and got a Civo provider, right? And so on and so forth. Like I'm working right now on some materials that I will probably publish in a few days, where I use this one, providers SQL, that allows you to do something with your databases no matter where they're running. So there's a decent number of providers outside of the official docs waiting to go into the docs.
Thanks. So there's also you work for a company called Upbound, and they have a SaaS offering that allows people to try this out relatively easily. Is that
correct?
Yeah. You want to share a little bit about that?
So yeah, if you go to Abound Cloud, you have basically a web UI that allows you to do stuff. And let me switch to the one that I'm using today.
So you're actually using
right?
Abound Cloud today, right?
Yes, yes.
Nice.
I did everything from the CLI. There we are, right? And this is the, oh, come on. It will happen, right? You can, you can browse things. I don't know why it's so slow. It's embarrassing. There we are, right? Look, I don't know, what did I do? EKS something, you can see the resources that are of certain name or certain phrases. You can consult them. You can see that all the providers that are having, like, for example, for AWS, those are all the types of resources or providers that we can use. Actually, the list is bigger because some of them have like multiple things inside. Like Elastic Compute has 7 resources in total. And then repositories where you can package your configurations and your code into a container, push them there, and make it even simpler to use. Users, themes, security, and all the things that usually enterprise companies are looking for. And we are soon to release a version of this that is self-hosted. Actually, there are 3 ways. Like when you create a new control plane, you can have it. Oh, that was too fast. I clicked too soon, right? You can have a control plane hosted by us. You can have a control plane self-hosted. That's Crossplane itself. And the third option will be what you see on the screen, let's say Abound Cloud to be self-hosted as well. It is. This is the hosted version is, I think, especially helpful if you just want to start and you don't want to set up Kubernetes cluster with Crossplane there. You just want to play around fast. Hosted version is brilliant. It just gives you in instructions. You get instruction. Actually, let's do it. Right. Test 1. I understand. Create control plane, and now this takes a few seconds. And you get the control plane only for you in a way, right? And all you have to do is execute the command to connect your kubectl with control plane.
Why do the control planes have a scheduled deletion?
Because we think of them more as a temporary solution for free usage. If you want to make it permanent, then you speak without sales, guys.
I got it. Okay.
There you go.
Still, 14 days usage to kick the tires on Crossplane, play with the providers, start building out your composite resources. That's enough time to get a feel for it and see if it's right for you and your organization.
There's another important thing. We're really trying nothing really. We are not keeping anything from Crossplane proprietary, right? We have things on top of it, like this cloud, web UI and stuff like that. But Crossplane itself, that's completely. So you can go for free from day one without really suffering at all.
All right. Okay, if you're watching and you have any questions, then please drop them into the comments section and we'll do our best to answer them before we finish. So I guess we've got 2 things, right? We're going to wait for this. Oh, there we go. It's already ready, so never mind. We now have our own Crossplane control plane that we can use. And that just, I'm assuming that just gives you a kubeconfig, right? Or something like that.
It goes to your kubeconfig. That's the whole gist. We just need to connect your kubeconfig with this. This is behind the scenes. This is a virtual Kubernetes cluster in our Kubernetes cluster. So we are stacking clusters on top of clusters for every user.
I don't know if you can go into implementation details, but I'm curious if it uses vCluster, which is a pretty cool tool in this space.
No, we are not, for a couple of reasons. Actually, to begin with, I love vCluster. I think it's absolutely brilliant. But we started before vCluster with this, or when vCluster was not a thing or popular or what's or not. So we have investment in. When we started, I think that there was no real solution like vCluster, and the guys working on it have some security concerns about vCluster. Actually, not security concern. The bigger thing is that now that we built our own solution, let's say, it is optimized for exactly what it does, right?
Yeah.
While vCluster is more generic. Like in that virtual cluster, we're not packaging the whole Kubernetes interface and everything, but only the things that Crossplane needs. It's highly optimized custom solution. But vCluster is awesome. I love it.
All right. Let's check on the status of our deleted node group. I'm curious about that. I wonder if Amazon's caught up yet. No. Come on, Amazon.
No, wait. I need to refresh. I'm never sure which parts of the screen are refreshed automatically and which are... okay. I'm not sure. Tell me if I'm on the wrong screen, but I think that I'm on the right screen.
You're on the right screen, yes. That has now recreated our node group.
Active. It was deleting. So there are two possible explanations. Either AWS gave up on deleting and said, I cannot do it, and I'm going to make it active again. Or Crossplane detected that there is a drift and corrected the drift.
Nice. What is
it's the latter.
What does our get node groups show?
Get node groups. Here we are.
Yes,
it's true.
Okay. All right, it fixed it. That's pretty cool.
Yeah.
And in fact, I think the node group name changed, right?
I did not really pay attention, to be honest. And even if I did, my brain cannot remember those random strings for more than 2 seconds.
Yeah. So. We got a comment in the chat from Ty who says that you have some great videos on vCluster and others. So yeah, I definitely encourage people to check out Viktor's channel. I will put a link into the show notes so you can check that out.
Oh, thank you.
All right. We have a question from Andreas. How do you manage credentials for the providers, and how can you restrict usage inside of the control plane? So like if I don't want everyone to be able to spin up a JKE cluster, how would that work?
So that's another kind of like, there are so many differences or advantages depending on how you look at it. So in traditional solutions, right? I mean, that's a wrong word, traditional. Okay, and other solutions, let's say traditional. When you interact with, let's say, AWS through, let's say, CLI, the user that is using that CLI needs to have access to whatever will be done in AWS, right? So you need to have permissions. If you want to create an EKS cluster, you need to have permissions for that. Your user needs to be privileged and what's not. Now, in our case, Crossplane itself is a, let's say, privileged user of your provider. You, as a human running kubectl commands, you are claiming certain resources in certain namespace, or you don't have to. Depends really how you configure it. So think of it as, let's say when you claim volumes in Kubernetes, right? Kubernetes has information and can authenticate to create a volume like EFS or EBS or whatever it is. You, as a user, admin of that cluster, gave you permission to create certain volumes in certain namespaces, right? So you need to claim them. So there are those two distinctions. What you as a person do, you're interacting with Kubernetes, and you have permissions to create certain Kubernetes resources in certain namespace. So I'm not going to do that now, but I could go and say, hey, there is a namespace Rawkode, and in Rawkode, you can create, let's say, resources GKE cluster, but I will never give you permissions to create EKS cluster, right? Because I don't trust you with AWS. You've been too negative towards it. And on top of that, and this is now plugging back into the whole idea of leveraging Kubernetes ecosystem, you can combine whichever RBAC you're using in Kubernetes itself, let's say with policies like OPA or Kyvern or whatever you're using, and further define things like, hey, Joe can, everybody in this namespace, they can create EKS cluster, but Joe can only do up to 3 nodes, and I don't know, somebody else can create up to 5 nodes. So whatever the rules are, right? So if you combine Kubernetes RBAC and policy management with whichever tool you're using, I would say that you're getting a level of both simplicity for the end user, but also control for others that is really not there with almost anything else that is not Kubernetes friendly, native, let's say.
Yeah, that makes a lot of sense. Crossplane is using the Kubernetes API, so all of these things should be implemented using the Kubernetes API. Definitely.
Yeah. It's more like kind of, you need to think about it differently, right? The question is not about the credentials in AWS or wherever you're running. It's about credentials to create or modify or delete specific Kubernetes resources. For majority of users, there is only Kubernetes API, nothing else.
All right. I hope that helps, Andreas. If you have anything else, drop it into the comments. All right, Viktor, is there anything else you would like to show us before we start wrapping this up for today?
No, if I go crazy, I will stay here for a couple of hours, and I think that we have a limit.
Yeah, I think we pushed our luck deleting the node group and seeing that coming back. So let's take that as a success. And
kind of as a parting gift, right? Just kind of as a parting gift, I will delete the whole cluster, and then we'll see whether it will come back by the time we wrap up.
Do you think it's going to delete by the time we wrap up?
Let's see. Usually those are the moments when I go and watch something on Netflix, so I never really paid attention.
All right.
I cannot because node group is attached.
That's all right. I trust you that it works. I think we see what we wanted to see with the node group. I think the one takeaway for everyone watching here is that, one, your interest in Crossplane should definitely be piqued. And secondly, the continuous reconciliation and working with the Kubernetes API, which hopefully you're already familiar with, brings a lot of superpowers to your infrastructure. I think it's just a fantastic, fantastic product. I'm going to pop back over to our big face mode. There we go.
Okay, it was so strange for me looking at the blank screen all the time. Where my terminal is. I will see your face, man. This is better.
Yeah, definitely. So just as we kind of wrap up, is there anything that you can share? Like, what are Crossplane excited by right now? What are you working on? What's coming soon? What challenges are you going to solve next? Like, just
So the major effort, let's say, or push right now is towards provider coverage. We need to get close to 100% for all the major use cases, right? So that's not really exciting. It's just simply the work that needs to be done, and there will be some very exciting news about that very soon. I cannot say the dates, otherwise. Grant, the one that was in comments, he's listening on this. He's the one above me. He's going to do something bad, and so most of the effort right now is in that. And then soon for next quarter, we're going to have some very exciting announcements, but I don't want to share it yet. So boring stuff, provider coverage.
Boring stuff. All right. Okay. Well, yeah, that's cool. It's nice that the provider ecosystem has been expanded on and elaborated on. I think it's just going to open up a lot more doors to people that want to use Crossplane. We got a thank you from Russell in the chat. So
thank you, Russell.
Yeah. All right. Well, we have no more questions. We're getting a few more thanks. People are telling us to leave now. I think that's what that means when they start saying thank you. So, Viktor, thank you so much for joining me today. Really cool demos to see composite resources, providing essentially an abstraction or a platform that doesn't really matter what the underlying infrastructure is. And I think that's a really cool thing for people to take away, that you can build these schematics for what a platform means in your organization and use that Kubernetes API to share them. Very, very cool indeed. All right. Any last words before I push the button?
Try it out, and if you get confused, then ping me on Twitter or LinkedIn or whatever. Find me somewhere.
Yeah, find them somewhere. Get the help you need.
Slack somewhere in Kubernetes or CNCF. Google me, and I'll help you out.
All right. Well, thank you again, Viktor. Have a wonderful day, and I'll speak to you again soon. Have a good one. Bye.
Thank you for watching Rawkode Live.